Hello, this is Dr. James Camp from Lee College in Baytown, Texas, and this is the third lesson in my Starting Off in C++ series. Our main focus today is decisions, if statements with else coming after them, switch statements with various cases. We're also going to talk about data types, character, integer, and double or floating point, and about the CN object and how you do input in C++. Okay, so today's project, we're going to be building a console calculator. A simple 5-function, plus, minus, times, divided by, raised to a power calculator. But we want the user to be able to type the phrase like 124 plus 321 and get the answer they're looking for. This requires some skills we haven't learned yet in this series, and that is, of course, the point of this video. First, we have numerical and character variables. Okay, we haven't learned how to read in numbers or characters from the input yet, or how to store them as variables. We haven't learned how to read them in from the input yet either, and that's where we need a new style of input using CN and the greater than operator. And then finally, to decide which math to do based on which operator they typed, we need to be able to make decisions. Okay, so first off, the first decision that the user needs to make is whether they want an integer math result or a floating point math result. There are two modes for math in C++, integer and floating point. The main difference between the two is how division works. If you look at, say, 7 divided by 2, where both of those are provided to C++ as integers, C++ will interpret that as you asking for an integer division. And so 7 divided by 2 is 3. It's actually 3.5, but there's no 0.5 in integer math, okay? So you just get 3. The fractional part is dropped. Now, if you do 7.0 divided by 2.0, where one or more of the operands is a floating point number, you'll get 3.5, which is more what you expect, because C++ will default to floating point division in that case. Now, you may ask, what happened to the 0.5 in the integer division? Well, if you think way back to when you were first learning to do division back in elementary school, when you did 7 divided by 2, you said, oh, well, that's 3 remainder 1. Well, there's actually a remainder operator in C++, which is the percent sign. Has nothing to do with the percent on a calculator that calculates an actual percentage. This is just, it looks sort of like a division sign, and so they chose it for the remainder operator. So 7% 2 gives you the remainder 1. Okay, so that brings us to our first decision. The user needs to know, or it needs to tell us, whether they want us to do integer versus floating point math. Okay, simple decisions in C++ look like this. There's an if with a condition in parentheses, and then there's a code block, which can either be a single statement or multiple statements in curly brackets. And that's the things that you're going to do if the condition is true. Okay, then there's an else, and then there's another code block, which again could be a single statement or it could be multiple statements enclosed in curly brackets. So how are we going to do this decision? First, we're going to ask the user what they want. Okay, this involves a prompt, which is an output line that asks for input, and an input statement. Okay, here's a prompt. Cout, type I for integer math or F for floating point. Okay, notice that I left a space after the prompt. This may seem like a silly thing for me to spend a minute on in a intro to C++ video, but it's very important for user interface design that you leave appropriate spaces for people to type their input. Okay, typing the input right after the word floating point without the colon and the space looks ugly, and it feels kind of uncomfortable to the user. Also note that I didn't put an end line in here. I don't want to jump to the next line and have the user type their input there. Most of the time, we want the user to type the input on the same line as the prompt. Okay, then we have to declare a variable to hold their answer. This is a character type variable, okay? A character is any letter or number or symbol on the keyboard, basically anything you can type at the keyboard, but it's interpreted as a symbol, not as a actual number. So if I type 1, I get the character 1, not the numerical value 1, and that's an important distinction to make. It actually is a number, something like 42 or something like that. That the number of the character in the ASCII representation system. Okay, once I've declared a variable to hold their choice, I can now read it in from the keyboard. CN, you may have guessed this from the fact that cout meant console output. Well, CN means console input. Okay, and all it does is read text and or numbers from the keyboard via the console window. So whatever console window you've got popped up, you type some numbers into that or some letters or whatever, and it's going to read that. And it's going to try via the extraction or input operator to put the next bit of text out of the console input stream into the variable on the right-hand side. So choice is a character, so CN is going to read a single character from the input stream and assign it to choice. So there's no chance of that failing. But if choice was a number, if I were asking them to pick a number between 1 and 10, say, type 1 for integer and 2 for floating point, something like that, then CN is going to read the next bit of information, and it's going to try to convert that into a number. If it fails, then CN fails, and the input operation is not successful. So be careful when you're reading in numbers that you actually read in a number. Okay. So after we've cleared those 3 lines of code, choice now holds a single character, either I or F, or lowercase I or lowercase f, because a lot of users are pretty lazy and they're not going to hit shift and type capital I or capital F. So now we can make our choice. Okay, if choice is I, then we're going to do the integer math part of our problem. If choice is else, we're going to do floating point math. So we're not actually going to check to see if the user typed F. We're just going to assume that anything they typed other than I is safe to do floating point math. Okay, a couple of notes on this code. To upper is what we call a function. Anytime you see a bit of C++ code, a C++ name followed by parentheses, other than like if or while, that's going to be a function. It's a pre-written block of code that does something for you. In this case, it takes the letter that's passed inside the parentheses and it capitalizes it if it's lowercase. Okay, that just avoids us having to check for capital I or lowercase I. It just simplifies the code a little bit. You may be confused about the double equal sign here. A lot of beginning C programmers are. The single equal sign is already taken for assigning values. So if I put a single equals there, it would try to assign the value I to the to upper choice, which it's a function, it can't hold a value, that would not compile. But if I had a variable there, if I said if choice equals I, it would try to assign I to choice, and that would not do what I wanted it to do. So the double equal sign is used in C++ for comparing values. In this case, it's testing to see if they are equal or not. Which means that this whole block here inside the parentheses is called a logical statement, okay? That is, it returns a logic value. Logic values are either true or false. So this whole statement here is true if choice is equal to I, and the whole statement is false if choice equals any other letter or number or symbol on the keyboard. Finally, this is a comment, okay? Comments have many uses. The whole point of a comment is that it's completely ignored by the compiler. So you can write whatever you want in a comment. You can say rude things to the reader if you want to, though I don't recommend that. You can make jokes. You can do all sorts of stuff with comments. The two standard things you do with comments are to explain what your code is doing if it's not completely obvious what that code is up to. And the second is to be used as a placeholder, as I'm showing here. I'm not ready to write the code that does the integer math yet, so I just put a comment in reminding myself that that's what is going to happen there. Some people even add the word to do at the beginning in all caps, / to do, colon, do integer math here, and that way they can do a quick search through their code and find any to-dos and see where they have code that they have left to write. Okay, so if we look at this now that we've broken it all down, if we look at it holistically, the first statement, if to upper of choice is equal to I, that means the user chose integer, and so we're going to do the integer math. Else, that means the user didn't choose integer. We don't know what they did choose, but we're going to default to doing floating point math. I could have put an else if to upper choice equals F, do the floating point math, and then an else, I don't recognize your choice. That would be the better user interface decision, but I wanted to keep this simple, so let's keep it simple. Okay, so in the first case, we want to do integer math. So I'm going to do a little aside here about numerical variable types. Integers are positive or negative whole numbers. Okay, negative 21 is a negative integer, 131 is a positive integer. Notice there's no decimal point and nothing past the decimal point. We couldn't have 21.1. At that point, it's not an integer anymore. Okay, so we're going to declare them this way using the int type, int num1, num2. Okay, you can declare multiple variables on a line using commas as long as they're all the same type of variable. In the second case, we want to do floating point math. Floating point numbers have a root and an exponent, okay, so that the decimal point floats. Okay, 3.14 has the decimal point in the right place. Negative 1.01 e negative 10, that's read as 1.01 times 10 to the negative 10th, okay? That's a very, very small number. 3.1 E6, that's 3.1 million. That's a very, very large number. And 0.0017, that again has the decimal point that would be represented in the computer as 1.7 times 10 to the negative 3. Okay. We're going to declare those using the double type. Now, some people get a little confused about double. There is a type called float. Float is pretty much, at this point, a deprecated type. Nobody uses it anymore because it is so low precision that it's rife with rounding errors and just low precision mathematical errors. So it's always better to use the double precision, which is actually often implemented as even quadruple precision in modern computers that have a lot of memory. Okay, in either the integer or the floating point case, we're going to write the same next lines of code. Okay, we want to read an input line this way: 1, 2, 3 times 4, 5, 45, say. That means we're reading a number, then a character, the operator, and then another number. In C++, we can do that like this. We declare a character called oper. We've already declared num1 and num2 on the previous slides. And so then we prompt cout, enter a math expression, and then we can cin num1, oper, num2. And notice that you can reuse the extraction operator multiple times on a single input line. Okay, that allows you to take multiple inputs from the same line of text and have the C++ input mechanism automatically split them up into multiple inputs. Not all programming languages let you do this. C#, for example, you have to read it in as a line of text and then break it on the spaces and try to interpret each thing individually. I think that's true of Python as well. Okay. Based on the character type variable oper, which we've just read in, we need to decide what math to perform. Okay. That's not going to be a single if and else like we did before, so we're not going to be able to be quite as simple. Now we need what's called an if, else if chain. And that is, the first if is just a normal if. Every other if is going to be preceded by the word else. And so it's going to say else if with a space. And so you have one if for the first condition, maybe plus, and then another else if for every other condition, minus, times, divided by exponent. And then the last one, the very last one, is else with no if. And this is a common mistake that my students make. There's no condition here. You don't say else and then parentheses and try to explain what condition is going on there. It's just else. And that is stuff to do if all of the other conditions fail. Okay, so in this case, it would only fall through to the else if the user hadn't asked for plus, minus, times, divided by, or exponent. So this would be just something that prints an error condition. Okay, so the first three look fairly straightforward. Okay, if oper equals plus, then we print num1 plus num2. If oper equals minus, we print num1 minus num2. If oper equals times, we print num1 times num2. A couple of comments on this. I put this little arrow symbol here just as a cute way of highlighting the answer. Otherwise, it tends to blend in with everything else on the console screen. This little double bar symbol is a logical OR operator, okay? That means it joins the truth values on either side of it, and the whole expression becomes true if either the left or the right is true. So if either side is true, the whole thing is true, okay? We couldn't use a logical AND because that requires both sides to be true, and the user isn't going to type two different characters. So OR is what we're looking for here. And this allows the user to type either a star for multiplication if they're used to doing math on a computer, or X for multiplication if they're used to doing math on a calculator. The next few are a little more complicated. Okay. For the divided by, we're doing integer division, so we're going to get a whole number and the quotient and then a remainder. So I actually have the output statement expanded so that it prints both the whole number quotient and the remainder. If oper equals caret, I'm using that for the raised to a power. Pow of num1, num2 is what we have to use because C++, whoever invented C way back when, did not seem to think it was important to have an exponentiation operator in the language. They apparently thought people who wrote C programs just never needed to do exponents. So instead, you have to pull the POW function from the CMath library. Okay, that means you have to pound include the CMath header, and that's going to raise num1 to the num2 power. Finally, we get the else. This is the one where it's fallen through every other if condition, so the user must have typed a invalid operation. And so we're going to print out error, I do not recognize operation, oper. Okay. There's an advanced, or you might call it alternate method for decision 2, which is when the variable you're deciding based on is a character or an integer type, something that has discrete values, you can use a switch statement. And the switch takes a variable in parentheses, and then you have to have curly braces, and then each case, a case label followed by a value, a single value, can't have a range of values or anything. Then it has a list of statements that you want it to do, each followed by a semicolon, and then you end each case with the break operator. Let's see how that works in real life, because it's much easier to see it than to explain it. So we switch on oper. For the floating point branch of our code, we switch on oper. Case plus, we're going to see out num1 plus num2, end with a break. Case minus, we're going to see out num1 minus num2, end with a break. Case star, we're actually going to fall through to case x. Okay, what that means is it's just going to combine cases star and x into the same output line there. Case slash, we do floating point division, and case caret, we use, again, the power function. And then there's a default case at the very bottom if it falls through all of the other cases, where in this case we're going to say the same thing we did for the error in the other case. All right, now let's see what this whole thing looks like. We type I for integer math or F for floating point. So I typed I, and I did 13 divided by 3, and it gives me this result 4 remainder 1. Okay, which is correct, and that's what I told it to do. If I type F instead and I do 13 over 3, it gives me 4.333 repeating, which is, again, correct and what I expected it to do. All right, so what we've learned today, we've learned about character, integer, and floating point double types. Okay, double precision floating point is what double stands for. We've done input using the CN mechanism. We've done decisions using if and else, which is the standard way of doing decisions. That's how most of your decisions are going to work. And we've done decisions using the switch case structure as kind of a demo of a more advanced, or at least an alternate way of doing simple kinds of decisions, or with simple decisions with discrete values, but multiple values that can be more efficient. Okay, so your assignment for this week for lab is going to be to take this calculator that I've written. I will post the code for you to look at and start from, and you're going to add a third decision at the very beginning. Instead of just integer or floating point, they're also going to get to choose functions, okay, mathematical functions. And at that point, they're going to be able to type something like sine angle, or log number, or square root number. And you're going to use the CMath library to pull those functions, and you're going to use ifs and elses to figure out which function they named and how to calculate the correct function for them, the correct output for them. Okay, so in other words, you're going to take my 4-function calculator and you're going to turn it into a mini scientific calculator. Okay, that's it for today. I hope you've learned something. Good luck and happy programming.